Assalamu alaikum. Student, we are discuss the remaining question of exercise 3.6. The question number 9 of exercise 3.6 is, if alpha beta are the roots of px square plus qx plus r equal to 0, p is not equals to 0, form the equation whose roots are alpha cube, beta cube. Question number 9 has 5 parts. Exercise 3.6. Question number 9. If alpha beta are the roots of px square plus qx plus r equal to 0, p is not equals to 0. Form the equation whose roots are we are doing part 1 of question number 9. In part 1, roots are alpha cube and beta cube. Solution. Okay, let alpha beta be the roots of the given equation px square plus qx plus r equal to 0. So the sum of the roots alpha plus beta is equals to minus p upon a. Is equals to minus q upon p. Because here a is equals to p, coefficient of x square, b is equals to q, and c is equals to r. And the product of the root alpha beta is equals to constant term upon coefficient of x square, which is equal to r upon p. This we call equation number 1 and this is 2. The question is find the equation whose roots are alpha cube and beta cube. Therefore, the required equation is given as by x square minus sum of roots of x plus product of roots is equal to 0. So the given roots are alpha cube and beta cube, x square minus alpha cube plus beta cube of x plus product of alpha cube and beta cube is equals to 0. Because we have to find the equation whose roots are alpha cube plus and beta cube. X square minus, here we use the formula alpha plus beta का whole cube, which is equal to alpha cube plus beta cube plus 3 alpha beta of alpha plus beta. So we put there, instead of alpha cube plus beta cube, alpha plus beta का whole cube minus 3 alpha beta of alpha plus beta of x, plus we can write this alpha plus beta का whole cube is equals to 0. This factor we get from this formula, alpha plus beta का whole cube is equal to alpha cube plus beta cube plus 3 alpha beta of alpha plus beta. So alpha plus beta का whole cube, this term is positive and the other side of equality will be negative. Alpha plus beta. So the value of alpha cube plus beta cube is equal to alpha plus beta का whole cube minus 3 alpha beta alpha plus beta. This formula we use many times in these type of question. And we know the value of the sum of the root and product of the root. Alpha plus beta is equal to minus q upon p from the given equation in the question, and alpha beta, the value of alpha beta we find r upon p. So we use these value of sum of root and product of the root in the given expression, the required equation x square minus alpha plus beta का whole cube. Alpha plus beta is equal to q upon minus q upon p. So we write here minus q upon p का whole cube minus 3 alpha beta, the product of the root, we write the value of alpha beta, which is r upon p, and similarly sum of the roots alpha plus beta is equals to minus q upon p of x plus alpha plus beta का whole cube. Alpha plus beta is equals to r upon p. R upon p का whole cube is equals to 0. X square minus q का cube upon p का cube minus plus 3qr upon p square of x plus r cube upon p cube is equal to 0. X square minus here we take LCM p cube, so minus q cube plus 3pqr of x plus r cube upon p cube is equal to 0. The whole term Taking LCM from whole term p cube. So here we get p cube x square minus minus plus का q cube minus plus minus 3pqr. अच्छा, this x will be multiplied from both term with both term q cube x and pqrx plus r cube is equal to 0. So we get the equation p cube x square plus q cube minus 3pqr. If you want, you can write by taking common x plus r cube is equals to 0. It is the required equation whose roots are alpha cube and beta cube. The required equation. Okay. The part 2 of question number 9. Question number 9, part 2. The question is similar if alpha beta are the roots of pq square plus qx plus r is equals to 0, from the equation whose roots are alpha plus 2 and beta plus 2. Similarly, you know that the value of the given equation is px square plus qx plus r equal to 0. Here a is equals to p, b is equals to q and c is equals to r. And the sum of the root alpha plus beta is equals to minus b over a, which is equals to minus q upon p. And the product of the roots c upon a, which is equal to r upon p. We have to find the equation having roots alpha plus 2 and beta plus 2. So the required equation is given by x square minus sum of roots of x plus product of roots is equal to 0. X square minus, here the roots are given alpha plus 2 plus beta plus 2 plus the product of the root alpha plus 2 and beta plus 2 is equal to 0. X square minus alpha plus beta plus 2 is 4 plus, by multiplying these two terms, alpha beta plus 2 alpha plus 2 beta plus 2 2s are 4 is equal to 0. X square minus alpha plus beta, this is the sum of roots, plus 4 plus alpha beta plus, we take common as 2 as a common from this, alpha plus beta plus 4. So after simplification we get the expression having sum of the roots and product of the roots in the form of sum of the roots and product of the roots. So we put the values of sum of the roots and product of the roots. That means alpha plus beta and product of alpha beta minus alpha plus beta is minus q upon p plus 4 plus alpha beta is r upon p plus twice of alpha plus beta is minus q upon p plus 4 equal to 0. After simplification, we find the required equation having roots alpha plus 2 and beta plus 2. Of x. Minus 2q upon p plus 4 equal to 0. X square minus minus q plus 4p upon p of x plus, here we take p as a common as LCM. So we take p as a LCM, p x square minus minus plus q x minus 4px plus r minus 2q plus 4p is equal to 0. Px square plus q minus 4p of x plus r minus 2q plus 4p is equal to 0 is the required equation having roots alpha plus 2 and beta plus 2. The third part of question number 9. We find the equation having roots 1 over alpha and 1 over beta. So the given equation is px square plus qx plus r equal to 0. A is equals to p, b is equals to q and c is equals to r. Sum of the root is equals to minus b upon a, which is equal to minus q upon p, and the product of the root is equals to constant upon a, which is equal to r upon p. The required equation is given by x square minus sum of roots of x plus product of root is equal to 0. Here we find the equation having roots 1 over alpha and 1 over beta. So x square minus 1 upon alpha plus 1 upon beta of x plus the product of root 1 over alpha 1 over beta is equal to 0. X square minus taking LCM alpha beta, so we get beta plus alpha of x plus 1 over alpha beta is equal to 0. X square minus alpha plus beta, which is sum of the root, and upon alpha beta is called product of the root of x plus 1 upon product of roots is equal to 0. So we put the value of sum of the root and product of the root here. X square minus sum of the root is minus q upon p and the product of the root r upon p of x plus 1 upon r upon p is equal to 0. X square minus minus plus q upon p upon r of x plus p upon r is equal to 0. X square plus q upon r of x plus p upon r is equal to 0. By taking LCM, here we get r x square plus qx plus p is equal to 0 and r x square plus qx plus p is equals to 0 is the required equation having roots 1 over alpha and 1 over beta. And the part 4 of question number 9, the roots are alpha plus 1 over alpha and beta plus 1 over beta. The given equation is px square plus qx plus r is equals to 0. And sum of the root is equals to minus q upon p and product of the root is equals to c upon a, which is equals to r upon p. And the required equation is given by x square minus sum of roots of x plus product of root is equal to 0. The roots of the required equations are alpha plus 1 over alpha plus beta plus 1 over beta of x plus alpha plus 1 over alpha, beta plus 1 over beta is equal to 0. X square minus alpha plus beta plus 1 over alpha plus 1 over beta of x plus, by multiplying these two terms, alpha beta plus alpha upon beta plus beta upon alpha plus 1 over alpha beta is equal to 0. X square minus alpha plus beta plus, we take LCM alpha beta, so we get beta plus alpha in numerator plus alpha beta plus, again we take LCM alpha beta, so here we get alpha square plus beta square plus 1 upon alpha beta is equals to 0. X square minus alpha plus beta plus alpha plus beta upon alpha beta of x plus alpha beta plus, here we put we use the formula of alpha plus beta ka whole square. We know that alpha plus beta ka whole square is equals to alpha square plus beta square plus 2 alpha beta. So the value of alpha square plus beta square we can write from this formula, alpha plus beta ka whole square minus twice of alpha beta upon alpha beta plus 1 upon alpha beta is equal to 0. X square minus, the value of sum of the root is minus q upon p plus minus q upon p upon the product of the root is r upon p of x plus r upon p plus minus q upon p का whole square minus twice of r upon p upon r upon p plus 1 upon r upon p is equals to 0. After simplification, we get the required equation having the roots alpha plus 1 upon alpha and beta plus 1 upon beta. Okay, the fifth part of question number 9 is the same as we have done all question of remaining question of question number remaining parts of question number 9. In part 5 we have to find the equation having roots minus 1 over alpha cube and minus 1 over beta cube. You can do easily from all this method. Now question number 10. Find the equation whose roots are double the roots of y square minus qy plus p is equals to 0. Find the equation whose roots are double the roots of the equation y square minus qy plus p is equal to 0. Solution. Let alpha beta be the roots of y square minus qy plus p is equal to 0. Here a is equals to 1 and b is equals to minus q and c is p. And the sum of the root alpha plus beta is equals to minus b upon a, which is equal to minus q upon 1, that means minus q. And the product of the roots alpha beta is equals to constant term over a, which is equals to p upon a, that means p. We have to find the equation having roots double the given equation. That means alpha is 2 alpha and beta is twice of beta. So the required equation is given by x square minus sum of roots of x plus product of roots is equal to 0. X square minus, we have to find the equation having roots double of this equation, that means the roots of this equation is alpha beta, and we have to find the equation having roots double of this equation, so twice of alpha plus twice of beta of x plus 2 alpha 2 beta is equal to 0. X square minus, we can take 2 as a common, alpha plus beta, which is equal to sum of the roots plus 2 2s are 4, and we get the product of the roots alpha beta is equals to 0. X square minus twice of, here alpha plus beta is equal to q plus 4, and the product of the roots alpha beta is equal to p. So x square minus 2qx plus 4p is equal to 0 is the required equation having root double of the given equation. And similarly, the question number 11 of exercise 3.6, find the equation whose roots are reciprocal of the roots of x square minus 6x plus 8 is equals to 0. So find the equation whose roots are reciprocals of the roots of x square minus 6x plus 8 is equals to 0. Solution. The given equation is similarly let alpha beta be the roots of width. The required equation is given by x square minus sum of the roots of x plus product of the root is equal to 0. This we call equation number 1. Let alpha beta be the roots of the equation x square minus 6x plus 8 is equals to 0. Here a is equals to 1, the coefficient of x square, and b is equals to minus 6 and c is equals to 8. And the sum of the root is equal to minus b upon a, which is equal to b is minus 6 upon a is 1 plus 6. And the product of the root c upon a is equals to 8 upon 1, which will be 8. By putting the value of sum of the root and product of the root in the required equation, we form an equation having the roots reciprocal of this equation. That means the roots of the required equation is 1 over alpha and 1 over beta. Because in the question, find the equation whose roots are reciprocal of the roots of this given equation. The roots of this equation is alpha beta, and we have to find the required equation having roots reciprocal of this root. So the reciprocal of alpha is 1 upon alpha and the reciprocal of beta is 1 over beta. So x square minus 1 upon alpha plus 1 upon beta of x plus 1 upon alpha 1 upon beta is equal to 0. X square minus, here we take LCM as alpha beta, so we get beta plus alpha of x plus 1 upon alpha beta is equals to 0. X square minus alpha plus beta is the sum of the root, which is equal to 6. 6 upon the product of roots are 8. So we put the value of alpha beta, which is equal to 8 of x plus 1 upon 8 is equal to 0. Here we take 8 as a LCM. So we get at 8x square minus 6x plus 1 equal to 0. Here 8x square minus 6x plus 1 is equal to 0 is the required equation having roots are reciprocal of the roots of given equation. So we have completed the exercise 3.6. Thank you so much.